Next, we will hear from Dr. Pat Levitt, Director of the Developmental Neurogenetics Program at the Institute for the Developing Mind at Children's Hospital, Los Angeles. Dr. Levitt is also Provost Professor at the Department of Pediatrics, Neuroscience, Psychiatry, Psychology, and Pharmacy, and W.M. Keck Chair in Neurogenetics at the Keck School of Medicine at the University of Southern California. Dr. Levitt has served as a member of the National Advisory Mental Health Council for the National Institute of Mental Health, is a member of the Dana Alliance for Brain Initiatives, a fellow of the American Association for the Advancement of Science, chair-elect of the Neuroscience section of the American Association for the Advancement of Science, and a member of the Institute of Medicine. He served as senior editor for the Journal of Neuroscience and currently serves on the editorial boards of several journals, including Neuron and the Journal of Neurodevelopmental Disorders. Welcome, Dr. Levitt.
Thank you very much. I also direct the Ph.D. program in neuroscience at USC.
You sleep 2 hours a night, right? Which is not good.
It's about, I have a granddaughter who has the same pattern of sleep that I've had for my life, and my son is angry about that. So I'm going to read my remarks because my family reminded me that I rarely speak extemporaneously for less than 10 minutes. Thank you for the invitation to speak. And you've already heard, it's interesting, there's a common thread that you'll hear from me that you've already heard. I'm going to focus on one particular area, which I call knowledge transfer and the responsibility, the professional responsibility, particularly in neuroscience, based on my comments. So there are time-honored areas of ethics training. I'm not going to touch upon those. Incidental clinical findings, use of subjects in research, etc. Every institution has a course in this. Some are wonderful, some are boring. But I think overall, at least from my perspective, there's a greater sense of professional responsibility in conveying what we're doing, the meaning, or what we've referred to as translation of scientific information, to the public and policymakers as a focus of ethics training. So, in essence, I think there's a problem in skill development and knowledge transfer in our profession and for scientists in general. And it's not just about using simpler words or shorter sentences, which is what I believed when I started in my public policy work 10 years ago. It's what social scientists and linguists and cultural anthropologists address in the context of strategic framing to address the challenges of conveying scientific findings accurately and fairly in the context, which we can't ignore, of cultural and social dominant frames that influence the interpretation and use of our information in society. People come to the table with a belief system, and we have to recognize that as scientists and understand how to convey our information in a way that is accurate and fair in terms of how it will be interpreted. So there are three areas that I think demand greater emphasis for training of students, research fellows, and I'll be honest with you, most faculty with whom I interact. So first, there's the ethical challenge of conveying the promises of neuroscience discoveries leading to disease and disorder cures or even improving human life experience. In 1997, John Brewer, who's president of the James McDonald Foundation, wrote a really interesting essay called Neuroscience and Education, A Bridge Too Far. In that essay, John speaks of the mistaken attempts to use speculation from basic neuroscience findings to apply in the classroom, the education clinic, because the studies were neither designed to inform best practices nor sufficiently vetted scientifically to demonstrate application. And there was this transition in the 1990s, the decade of the brain, which put the bridge too far, I think, onto our collective plates. That there was a sense among some that we continue to expand through that decade and now promises unkept. Neuroscience holds a special place, I think, because we believe that through our capacity to gather an unending amount of information, we will eventually discover the signature patterns of mental and physical states. Ultimately, the ability to use the collective data on genomic and brain activities that provide a fingerprint, perhaps, for illness. And then we pose to our students all the time the following questions. If you had the entire gene sequence of an individual, would you know whether or not they had schizophrenia? If you could define every connection in the brain of an individual, would you be able to determine whether that person has major monopolar depression? And granted, trainees and scientists understand and recognize the complexity of the interplay between genes and environment, brain plasticity, the staggering amount of information that will be extracted from the coming generations of technologies, data management, and analysis, which we're going to hear more about today. But we must understand that the public will have a very different view. That's the reality. And we can't say it's their responsibility. We just put the information out there. They will not recognize the subtleness of the nature of how we interpret data and draw conclusions when we insert disclaimers, which we do all the time, such as may, possibly, perhaps. Can we recognize and emphasize in our training, through example, best ethical practices for conveying what we know, how we know it, and what one can do and cannot do with this information? Second, now more than ever, we are embracing the goal of leveraging both animal and human studies for practical application. Since the 1990s, translational science, particularly translational neuroscience, has been a core principle from which our science funding agencies have operated. And lately, the principle has come under fire in discourse between scientists, attacking this as the culprit of our current woes in funding and publications, journals driven to publish the next New York Times or Washington Post covered article, push the envelope, insisting on the use of terminology, shared nouns, to emphasize the importance of the next great discovery. I'm just laying out what the problems are. I don't actually necessarily believe that is the culprit in this. We talk to our trainees and junior faculty about paying careful attention to the benefits of what can be studied only in animals and the caveats against unwarranted generalizations and inappropriate application to human health. For example, is it fair, or is it even ethical, is it an ethical question, to use the term autistic mouse when Kanner clearly described the constellation of symptoms in 1943 that come together that we use to define the clinical population, and we know does not coalesce in animals. That doesn't mean that animal research is not valuable. I do that as part of my laboratory effort, but describing an autistic mouse has an interesting meaning to it. What are the ethical considerations of describing and promoting one's research in this context? What are the ethical considerations in the context of a growing scientific culture, which I strongly believe, in which we cherry pick clinical literature to support the relevance of an animal phenotype that may or not be translatable to the human condition? The biology may be translatable, but the translation to direct impact on human disease and disorder understanding may not necessarily be. That doesn't make the research less valuable, but it's a different way for the public to think about it. In essence, are we purposely misrepresenting research deliverables to trumpet discoveries that provide high science currency, journal impact, grant dollars, whatever it might be? And I view this as an ethical issue that we need to address. And third, there is a continuing evolution of the concept that most brain diseases, and even other types of diseases, has a developmental etiology, a topic that is rarely covered in ethics courses. From genetic discoveries that clearly demonstrate early risk to epidemiology of large populations that show intergenerational impact of environmental factors that increase risk for mental and neurological disease, there are whole institutes now at the NIH that have been dedicating substantial resources towards the goal of determining the origins of developmental risk and then translating these research findings into prevention strategies in our community. There's a paper that appeared last week on brain growth and SES, et cetera. And so we're seeing more and more of this up here. In 2007, I co-wrote an NIMH Council report with my partner, child psychiatrist John Marsh. The report articulated a set of short and long-term goals to expand research efforts on the neurodevelopmental basis of mental illness. Keep in mind that this developmental emphasis was espoused in the 1970s, but represented an occasional, as I call a faucet drip of research going on, compared to the current tidal weight of neuroscience research in this area now. Of course, I may be biased, because that's what I do. I'm a developmental neuroscientist. I think the emphasis is well placed in terms of an important research investment and its potential impact on society. However, how we considered sufficiently the ethics of the short and long-term impact of neuroscience research through critical periods, for example, in defining the future of individuals who have experienced a type of toxic stress, neglect, abuse, violence, parental substance abuse, poverty, that dramatically increases risk for later mental and physical illness. Are we in a position to speak about the irreversibility of a developmental recipe for mental and neurological disease that has a developmental etiology? From my own unofficial survey of neuroscience graduate programs, most standard ethics courses don't touch upon this topic, yet the public, service providers, and policymakers want to know. I spend a fair amount of time talking about the science of child and brain development, and what these groups want to know is the following. What is the future for children who have experienced the heritable and non-heritable factors that increase risk for these disorders? Conversation about stress response systems being tuned permanently, the so-called permanence of epigenetics, critical periods, which implies a time domain that has generated the metaphor windows of opportunity. All are conceptual frameworks for our neuroscience research, but how do we address how data that emerge from these studies are interpreted and used by policymakers and society? Finally, in 33 seconds, I want to emphasize the gap between what we know and what we do. It still exists. Families, policymakers, service providers are desperate for information from science that will help them make decisions that will improve their relatives and the millions who live in their communities. So recently, I was at Bowdoin College as part of a 2-day symposium on policy implications in child and brain development in Maine. So I met with 25 brilliant undergraduates, and we talked about what I do and how a basic scientist got into policy work as part of my role as scientific director for the National Scientific Council on the Developing Child. I explain that when I speak to policymakers and legislators and business leaders, I talk about science, current misconceptions due to dominant cultural frames, and science policy gaps. But I stop short of recommending specific policy solutions because I don't do research on interventions and policy. And I can tell you that it frustrated a lot of students. What do? They didn't really understand what I did. How do you, if they don't pass legislation or do something, how do you know that you've been successful? And I explained, I'm not a policymaker. But I've heard well-intentioned neuroscientists provide recommendations or promote activities or programs that they believe would be best for the community to incorporate. We're smart. Neuroscientists are smart, if I must say so myself. But are we really equipped to make decisions between 4 intervention programs unless we are intervention researchers? And is it ethical for us to promote ourselves as decision makers in domains that all logic would state that we have no business being in? So it's about training the current and next generation to recognize when they are participating in building a bridge too far, which is an issue of personal and disciplinary ethics, and when they are being true to both the promise and limitations of the science. So thank you.
Thank you very much, reminding us that Socrates said the highest form of knowledge is knowing what you don't know. But you also, without rehearsing, the 3 speakers have taken us from understanding that teaching isn't the same as learning, and for scientists to learn both cognitively and emotionally, the importance of ethics is important. And now Dr. Levitt, it's important not only for scientists to learn, but what the larger community learns, and scientists and we all have a responsibility for communicating in a way that we understand what people actually hear. So thank you very much.